Okay, so we're recording, and what we want to do with this video is we want to explain how to use, get started learning how to use LTSPICE, and I'm going to also talk about Ohm's law just to give us a real gentle introduction. Once we've installed LTSPICE, I'll talk about doing an operating point analysis, a transient analysis, and a DC sweep. So circuits will be very simple, but it'll give us a starting point and some examples so we can start playing around on our own. So first thing we're going to do is we're going to go to this website, cmos.edu.com. cmos.edu.com. And I'm going to click on LTSPICE right here. Okay, there's also tutorials and other videos you can see here, but for now let's just click on LTSPICE. And this page tells us some things about LTSPICE. Let's just look at this bullet right here. So LTSPICE, which is also known as SwitcherCAD, is a powerful and easy to use schematic capture program and SPICE engine without node or component limitations that can be downloaded here. So let's go ahead and download it. And let's see, I think that's the one we want right here. Download LTSPICE. And would you like to, I just want to download it, I don't want to register, so say no thanks. And I have it being downloaded to the desktop, and looks like that's going to be fairly fast. But while that's downloading, let's go back and I want to just actually, before we get going too much, let's start the installation because I don't know how long that's going to take. And it's got this little thing here, so maybe I have to right click and say run as administrator. Yes, and accept, install now. Okay, this is the computer I use for recording the videos, so alright, so it's going to take a little while. So while that's chugging around here, whoops, what just happened? Let's restart the camera. Full screen, autofocus, make sure it's nice and focused, and it's not. Alright, so before we get going, let's talk about Ohm's law. So we downloaded LTSPICE and I just installed it. So let's get rid of this then. So this is the LTSPICE has been successfully installed. Get rid of that, and then this will be the icon we use to start LTSPICE. Okay, so let's go back and talk about Ohm's law. And you probably, many of you may know Ohm's law already, but I'm going to go over it again anyway. And so we have a battery with a symbol, and everybody's used batteries before, with a plus side and a minus side. And the battery has some V or voltage. And so we might have a battery that's 9 volts, or it might be like one of your little calculator batteries, which is 1.5 volts. We connect the battery to our circuit with wires. And then we'll go to some load, and load might be your hair dryer, it might be a battery charger, it might be a computer, it might be a TV, but for what we're doing here, we're going to call this load some resistance, and I'll talk more about this in a moment. Okay. Before we move on with the electrical part, let's go talk about a water analogy. Let's say that I take a pump, a water pump, and I connect with big pipes the water pump to a smaller pipe diameter. So this I'm going to use as a pipe, and the diameter of the pipe I'm going to restrict. So the smaller I make this pipe, the more resistance to water flow there is. So if this distance d goes down, gets smaller, then the resistance of the pipe, R, and we've drawn a resistor here, R, or resistor here, R, will go up. So if we make the pipe diameter smaller and smaller and smaller, we get less and less water flow because the pipe restricts the amount of water flow. The pump will generate a pressure. Ideally, the pressure stays constant, and we'll get some water flow here. Through the system. So let me review. We got a pump, we got some big pipes going over to a little pipe, so we don't worry about the resistance of these big pipes, just the resistance of the little pipe. And then we look at how, if we increase or decrease, so if we increase the diameter, then the resistance goes down. It's easier for the water to flow. So this analogy, we have a pressure here which corresponds to a voltage here. And we always have to have some reference, even though it's just a reference for our pressures. So we could do that as ground, which we'll call our reference. So we have some voltage here in this circuit. We have some pressure here in this circuit. When we connect a pipe up, say a small diameter pipe, which we're going to say has some resistance, we get a water flow. So if we take the pressure and we divide by the water flow, we get some resistance. So if the water flow increases, that means that the resistance is going down. If the water flow decreases, that means this resistance is going up. So we're just repeating what we have. Notice that without the pipe here and without a closed system, we can still have pressure but no water flowing. Okay. So in circuits, we have a voltage here. We get some current that flows I, and we then say V over I, where I is analogous to the water flowing. V over I is equal to the resistance, or writing a different way, V equals IR, and this is Ohm's law. Okay, so let's now go do some simulations and see if Ohm's laws really works, and show how to plot things and all that stuff. So let's hit escape, minimize this, and now this, let me maximize this, but this first lecture, what did I call it? Let's just call it, let's make a folder, and let's put, let's call a folder, and let's call it EE220D video 1. Okay, so let me close LTSPICE again. We're going to start it up. I'm going to go to File, New Schematic, and notice it's gray. So I'm going to change a few things. I'm going to save it before I get going, because right now it's called Draft 1. I'm going to save it as, let's go save it on the desktop in this folder, so you can later on save it as whatever you want. Let's call it OP, let's do operating point example. Okay, so now I don't like the gray background, so first, before we even do that, let's go open this up and see what we have. So there's so if we were to quit now, or when you unzip this after you download it, all you have to do is double click on the schematic to open it. Okay, there's nothing there, but let's, I like white background, so let's go to Tools, Color Preferences, Schematic. I'm going to click the background. I clicked on it, or you could go select it here. And I'm going to move the cursor over to 255 on each one. I'm going to say OK. And it looks like a blank screen, so I like having a grid. You can do it the way you want, but I'm going to go to View, Show Grid, or Control G. Okay. All right, so we're ready to draw our schematic. First thing we're going to do is we're going to go up here and we're going to click on this resistor. So now after I do that, I want you to come down here and look what's happening in this lower left side here. So if I come down, you can see I can do a Control R to rotate or a Control E to mirror. So if I do a Control R a few times, it rotates the resistor around, or if I do a Control E, it mirrors it back and forth. You know, right now that's not that important, but when you get to making more complicated schematics, all the little tricks that you can have to help speed up the drafting are nice. So I put down the resistor, then I'm going to hit Escape. This is the resistor's name. All resistors have to have names that start with R. So why don't I right click on this resistor and I call this R, let's call R load. Just as it's a load, it's representing our charger, it's representing our heating element, it's representing our computer or whatever we're supplying electrical current to. You don't have to rename it, I'm just doing it to show you how to do it. Then R here is the value. So I can right click on that and change the value, or I could right click on the resistor and change the value here. Okay? Let's just keep it simple and change the value. And let's say that our resistor has a resistance of 1,000 ohms, and that'll be 1K. Okay? So that means 1,000 ohms. Next thing I want, going back and looking at my simple schematic here, is I want a voltage source. Okay, so let's go grab a voltage source. So now if I go up here, I see this AND gate. This is something you have to remember because there's no voltage source up here. I see this AND gate. That is the component. That gets me my component menu. Okay, so I'm going to click on that, and then I'm going to go to just where it comes up. You'll be good to go. I'm going to click on voltage source, and there's the symbol, and I hit OK. So I'm going to go drop that. And you know what? I think I'm going to do a Control E just to flip the labels around. Now I hit Escape. And then I'm going to, let's call this V source. I like pretty schematics. So, and let's say this is 1 volt. So you can put 1V or just 1. Last but not least, I'm going to use this wire tool here to draw a wire. Now if I wanted, I could also hit F3 to draw the wire. Okay, just like I could hit R to add the resistor. These are called, in other tools, they're shortcut keys, but in more advanced CAD tools are called bind keys because the keys are bound to doing a specific thing. And when you get really good at drawing schematics, you don't need to use the menus too often. You can just use the bind keys, like you could hit F2 instead of going up to the NAND gate. So anyway, I'm going to continue using the menu, and I'm going to draw a wire. And oops, I made a mistake. So I'm going to come back here, come down, come around, go up, then hit Escape. And notice when I finish the circuit, it automatically stops drawing. If I want to stop drawing at some point, I can hit Escape. But I made a mistake here, and I don't want that piece of wire, so I'm going to come up here to the scissors, and I'm going to cut it. Okay. Further, I want to move this 1 volt over here, and I kind of want to move, let's say I want to move the V source below. So I'm going to come up here to this big hand, which is Move. So I'm going to move the 1 volt here. Again, I'm showing you this just so you know how to do it. There's nothing wrong with the way things are set up right now. Okay. And if I grab this, it moves the resistor, and I can hit Escape and get out of the mode. But now if I grab the little hand, that's drag. So if I drag the resistor, I can move it places. If I wanted to drag part of it, I could do this. Okay, so moving and dragging are pretty important. Now, this circuit doesn't have any reference. I mean, we can talk about pressures, but they have to be, or voltages, but they have to be in reference to something. So I'm going to come up here to ground, and I'm going to grab ground, and I'm going to go to the bottom, and I'm going to put a wire up like this. And now this is, if you learn anything here, this is a circuit, circuital, from the word Latin circuital, because the water or current will flow around like this. The pump creates a pressure here, flows back around and back into the intake of the pump. No current flows in this ground. It's just there as a reference. There's no path because it's not part of a circuit. It's just providing a ground. Oftentimes we will be lazy, or I'll be lazy especially because I don't like lots of wires, and I will get this ground and I will draw the circuit to look like this. When you do this, it's understood these 2 points are connected. Okay, so it's a lazy way of not drawing the wire. So if I go and put the cursor on here and I right click and I put highlight net, it shows those 2 nodes are wired together. Okay, so let's go, because we're learning circuits, we want to keep everything in circuital shape. So let's go and it doesn't matter where we connect the wire up. And one of the things I found when I was learning circuits is if you think about how you would connect wires up, you don't get bogged down with these straight lines. You think, oh, I connect a wire. If it was in my house and I was doing wiring in the wall, I connect a wire up over to this point. Well, it doesn't matter if I connect that wire 2 feet off the ground or 6 feet off the ground. It's still a wire represented going over to some source. Okay, so we're ready to do a simulation. So we could start the simulation by clicking this guy. And I'm going to do that just so you see what happens. And it would say, what kind of simulation do you want? Okay, so maybe before we even do that, we should hit save. Then when we come back here and do op example, there's our circuit saved. And you want to do this regularly because it's much easier to modify things that you have instead of redrafting. Drafting the schematics can take a lot of time when you get to more complicated ones, so cutting and pasting is important. Okay, so let's for this first one, let's go ahead and hit run, and then I'm going to select this DC operating point and just hit OK. Notice before we look at the results, well, I guess you see .op, it put it in the schematic, okay? So I'm going to go ahead and look, and I see VN001 has a voltage of 1. So I don't know where VN001 is, so let's see. Okay, if I look at the bottom down here, it tells me this node voltage is 1 volt. N001 is 1 volt. Down here, the node voltage is ground because it's tied to ground. So it's 0 volts. And in SPICE code, which we can look at, let's see, SPICE netlist under view, the first line in a SPICE netlist, and if you're going to be an electronics guru and you need to know what your tools are doing, and all that the schematic does is it generates this netlist, which is just a text file. So it's good to look at what's going on. You look here and you see a text line, which is a title. Then you see a resistor, which is connected from N001 to 0, and that's 1K. This node is N001, this is ground, and the resistor's value is 1K. And it's important because SPICE always ignores the first line, so if you start doing net lists by hand and you don't put a title line for your first line, it can be frustrating because the simulator will ignore it. And that's the way all of the SPICE simulators are, even the most advanced ones. They always ignore that first line. The next line says there's a voltage source, because all voltage sources start with V, all resistors start with R. And it says there's a voltage source between N001 and 0 or ground. Again, ground is always node 0, and it's 1 volt. .op says that's the kind of analysis. Back annotate as a SPICE code so that, if I remember correctly, the net list is, I don't remember. I think it's backward compatible, but I really don't know. You could look it up in the help. and .end is says that's the end of the net list. Okay, so let's close this. And I don't like this node being called N001. Since the pressure here, or voltage, it's physically tied to this voltage source, is always going to be V source. I'm going to name it the same as this. I'm going to come up here to this label net and call it V source. Come down, hit escape, rerun the sim, and now I say, hey, the voltage of V source is 1 volt. Now without rerunning the sim, I can just go plot the visible traces. The current through the load is 0.001. Well, let's verify that. Let's see if I have, let's change colors. If I have 1 volt divided by, or whoops, we need to change this and solve for I, over 1 kilo ohm, which is I over R, then the current that flows is 1 milliamp. 1 over 1 divided by 10 to the 3 equals 10 to the minus 3, which is 0.001. So that's correct. Okay, so let's hit escape. Now, before we go, what we just did was we said, hey, V of the voltage, and it has to be V of this node, which I called V source. It doesn't, the node name can start with anything. Okay, so I have V of V source and R load, so I have 1 volt, 1 K. The current that flows is 1 volt over 1 K, or 1 milliamp of current. Now there was one other parameter, which was what was the current flowing in the voltage source. And that is I of V source, and it says minus 0.001. That shouldn't confuse you, and you should remember this, because if you don't, when you're trying to verify your homework solutions with SPICE, which in my, when you're learning, if you simulate your homework first and you know what the answers are, then you can verify or do your hand calculations. But SPICE defines positive current flow as from plus to minus. So even though the currents or water's flowing like this, SPICE defines a positive current through a voltage source is from plus to minus. Okay. Now, if I take this resistor, it just happens I put it in the right way, and I'm using the big hand, and I hit Control R, and I flip it around, and I rerun the sim. Now, the current through that resistor is also negative, so don't let the currents being negative confuse you. It's just how SPICE defines positive current flow. So we can go back, hit Control R, and flip the resistor around, because the resistor is just a pipe. It doesn't matter which side you connect where. Of course, you can't flip around the voltage source, because if you do that, then the pressure changes. Instead of having a positive pressure and pushing current like this, if you flip it around, you get a negative pressure, like taking the drink out of your soda, and it pulls the water or pulls the current backwards like this. Okay. All right, so let's go ahead and hit File, Save, and then close it and see what's in our folder. So this is our schematic. This is our log, which we could open with a text file. And if I double click on this, it opens the information. Well, a lot of times you may not want that, especially if your simulations are getting big. Here the simulation's about as simple as it can get. So what I'm going to do is I'm going to reopen my circuit here, and I'm going to go to Tools, Control Panel, and I'm going to hit Operation, and it says Save all open files on start of simulation. No, I don't want to do that. I want to save them myself, because I may be experimenting and I don't want to save the experimentation. Do I want to delete the raw files? Yes. Delete net files? Yes. Delete log files? Yes. And this is up to you. You can do this if you want. Delete fast Fourier transform files? Yes. Now I'm going to hit OK. Now notice if I hit Run, I close the schematic, watch what happens. It's nice and clean. Okay. All right, so that gets us through. And I went through a lot of things there that may not be useful right now, but if you learn them in the next few years when you're taking electronics or you're taking analog integrated circuit design or whatever, and you know this already, it makes your life much easier and you have more power in getting things done, okay? So we've covered Ohm's law. We've talked about an operating point. Now let's talk about a dot tran. So I'm going to do this two different ways because I want to show you how to copy. I can open this up. I can do File, Save As. Let's come down here and save it as tran. And now if I close it, I see there's two examples. If I go here and right click on the .op, I can go transient. And transient means that I'm going to be simulating the circuit for a time. .op just says, how does this circuit operate at a DC, in steady state when that pump is just running, there's no changes in the current. And then the first month or so, that's all you'll do is DC circuits. So there's really no difference between a dot tran and a .op. It's just with a dot tran you can plot things versus time. And I'll show you what I mean right now. But before I do that, I'm going to hit 1 as simulate for 1 second, somewhat arbitrary. I'm going to hit OK. If I hit run, you'll see now that this waveform screen pops up. So if I click here, it tells me everything I can plot. So if I plot V of V source, that's the voltage of this node right here, okay, which I can click on as well with my probe. I'm going to see it's at 1 volt. Of course it's 1 volt. The battery's holding it at 1 volt. If I come over, I can put my cursor over the resistor, and now I can plot the current through the resistor. And you can see here the current is on one side, the voltage is on the other. I can right click and I can go add plot plane. Now notice, before I do anything more, my cursors aren't showing up. This is important to avoid frustration. My cursors, like the voltage source or the current, aren't showing up. And the reason they're not showing up is I don't have this window selected. So when I come back here and select the window, now they show up. But I'm going to come up here and I'm going to select this window. Then I'm going to grab this and I'm going to drag it up. Now again, I like to see plots that have graphs, so I'm going to go grid. So I'm going to go turn the grid on and I'm going to maximize that. Then I'm going to do a few other things. I'm going to go to my control panel. Whoops. Go to my control panel and I'm going, because my eyes aren't as good as they used to be, I'm going to go to operation and where is it? Waveforms. Plot data with thick lines. Okay. Then I'm going to go up to the tools again in the color panel, and I'm going to change tools, color preferences, make sure my waveform tab is selected. I'm going to select the background is white. Then I'm going to go grab the axes and make them all black. If you don't do this, then when you copy things, and then the inactive axis, because one of them will be active plot and the other will be inactive, I'm going to make that one black as well. Then I'm going to hit OK. So now if I want to copy this image for whatever reason, I can go up to copy bitmap to clipboard, or my favorite way of doing things is to use the accessories snipping tool, and then let's see, are we on rectangular snip? Oops. Let's do it again, new, and then I could just say, oh, I take this part, and then I can save it and do whatever I want. Alright, don't want to save it. Now, here's an important thing. Before I go close this, or actually, why don't I close it and just close the simulation. Do I want to save changes to .asc? So if I go look, the .asc, oh, we can't see the extension here, is this file right here. So I'm going to say yes. Okay. Now when I go run the simulation again and I hit run, none of the stuff I just plotted shows up. I don't like that. Okay. So I'm going to redo this. So if I plot like this voltage, and then I go right click, add plot plane, and I can come back here, select that window, click here again. If I come up, select this window, and I hit save, and before we do that, all of this stuff is going to disappear when I close the simulator because I set it to in the control panel. But what I'm going to do by saving this is I'm going to get a PLT file. So I hit save. I come down and now there's this PLT. This is plotting information, and it's used by LTSPICE to automatically plot stuff. Whoops. So when I hit run, it all plots what I had before, and I can maximize, I can copy the bitmap. One other thing I can do is I can right click here and I can say, oh, I want to subtract, let's see, subtract 1 milliamp. Oh, now it goes to 0 because I subtracted. Or I can multiply, or I could take the derivative, okay? Or I can multiply two traces. I could go, you'll find out about power. I could go, well, what's the power? I could go times V of V, whoops, V source. And now it automatically knows. And you don't know at this point what that means. But just the whole point is you can come up here and change what you're plotting by right-clicking. Okay, so let's close this, and then I'm gonna leave this file here, but I'm gonna delete this one, and I'm gonna do this from scratch. I'm gonna come up here, I'm gonna close this, and I'm gonna go File, New Schematic, File, Save As. Let's save it in. What is it called? Example. Okay, so now if I go back, hold on a sec, why did that? Oh, I saved it as a symbol. Let me try it again. Let's start it from scratch. Let's go File. Oh, I hit New Symbol. That's why I saved it. All right, File, Save As, and then go to the desktop, go to my little folder, click on that, and go boom. Okay, so now I have to redraft the whole schematic. I don't want to do that. So what I'm going to do is I'm going to go up to Open, and I'm going to open this. Then I'm going to use this minus and zoom out a little. Then I'm going to come over here to this clipboard looking thing and do Copy. Now LTSPICE doesn't use Control-C and Control-V and Control-X. It uses the clipboard here, and you have to have both schematics open, and that takes a little bit of work to get used to. So I click on this, I drag it around here, okay, so I can copy within this schematic, but I don't want to do that. What I want to do is come over here and drop it down. I'm going to go back and close this one. Then I'm going to hit this Fit, Zoom to Full Extent, right click here, and then I'm going to change it back to a transient. Stop time 1 second. Notice when I copied it, it changed the names. That's important because you don't want the same names of components. So I'm going to quickly go back here, change those back, hit run. Let's hit save first and then run. And because I had that PLT file there already, it automatically plots. Okay, so let's hit save. Let's hit save and just review. Okay, all this will go away. We don't need a PLT file for the operating point. Let's move the .o piece so the schematic looks a little nicer, and let's put it right here. Hit fit. Guess it looks a teeny bit nicer, not much. So if I hit run, tells me what the operating voltages and currents are. So use this a lot in the first month or so of Circuits 1. Okay, the .op, because you'll get a homework problem, and we'll do this next week when we have the discussion session. But we'll get a homework problem, and then you just put it in LTSPICE, do a .op, and then you see what the answers are to every voltage and current, and all you have to do is algebraically verify your answers. So I can go, okay, the voltage here, now keep an eye on this part right here, is 1 volt. The current through here is 1 milliamp. The power dissipation of the resistor is 1 milliwatt. Power dissipation is voltage times current. So that's what a .op does. The transient does things in the time domain, in the time domain. So when I hit run here, I've got it automatically plotting. I've plotted V source. I've plotted the current question. The same current flows in this entire circuit. So if I plot the current through the voltage source, let's select this plot, come down here, select the current through here, what am I going to get? Right, because SPICE defines positive current flow from plus to minus, I'm going to get -1. So there's my -1. But if I want to show they're the same, I could then go put a minus in front. Or let's see if the absolute works. I don't remember what the exact syntax is. It'll tell me if I'm wrong. Oh, okay. Guess that's right. I don't want to say that, but just something to look at. Now, before we go on to our last type of analysis, because we know what a .op or operating point is, we know what a .tran or transient is, I want to look at the SPICE netlist one more time. So I go here to SPICE netlist under View, and I see R load V source 0, 1 kilo ohm, V source 0. Again, this is the node name. If I go change this name to Jake, and then I go View SPICE netlist, now it says there's a resistor from node Jake to ground of 1K and a voltage source from Jake to 0 of 1 volt. Okay, so the name doesn't matter. It's just something for humans. The circuits don't care. But comparing this netlist to the operating point, the only thing that we're going to see that's changed is that .tran. And when we do our next type of analysis, which is a .dc, we're going to see something similar. Okay. All right. So let's go ahead and hit save, close, and let's go back here, full screen. And then for our last simulation, we're going to do a DC sweep. And that's a .dc. So what I'm going to do is I'm going to take this voltage source or pump, and I'm going to sweep the pressure. I'm going to cause it to go from, say, 0 up to 1 volt. And then I'm going to see how much current that flows. And let's still use a 1K. Well, we know Ohm's law is V equals IR. We know the current that flows in this circuit will be V over 1K. And let's just make sure I'm complete. Units here are volts. Units here are amps, which are coulombs per second. You already learned this from physics, so I'm repeating. And then the resistance is measured in ohms, which has a symbol capital omega in Greek letters. So if we have 0 volts here, there's no pressure, no current flows. If I have 1 volt here, we have a current that flows of 1 milliamp. So if I sweep the pressure, I racket up the pressure from 0 to 1 volt, I get a current that flows from 0 to 1 milliamp. So the water just starts increasing. And if I sweep it linearly, then I get a linear increase in the water flow. All right, so let's go, and I'm not going to copy this time. Let's just go ahead and right click on this, and let's change it to a DC sweep, and I'm going to sweep. The name of the source is V source, and I'm going to start at 0 volts. I'm going to stop at 1 volt, and I'm going to have 1 millivolt steps. So we'll go 0, 1 millivolt, 2 millivolts, 3 millivolts. That's a reasonable value. Hit OK. Get my little hand. I like clean schematics, so let's go over here. And now this 1 volt doesn't mean anything because I'm sweeping the source from 0 to 1 volt and looking at the current that flows. Whoops, before I do anything, I've got this as tran. I better save as, which I normally do first. So let's change this to DC. Hit save. And then, as the author of LTSPICE says, I'm going to poke the running man to start the simulation. And of course, we have no PLT file. So if I go look, there's only a PLT file for the transient. So what I'm going to do first is I'm going to look at the pressure or voltage V source. Of course, that's anywhere on this top wire. And if you look here, the x-axis is the voltage source, V source, being swept from 0 to 1 volt. So if I plot what the voltage is here, it's going to be a voltage which is sweeping from 0 to 1 volt, or a line with a slope of 1. Not too interesting. So now I'm going to go back and add a plot plane. And I'm going to plot the current that flows. I got to click on the window. And sure enough, let me go ahead and save this before I forget, and save this one. This current goes from 0 to 1 milliamp, and that's because it's V over R. And so if we look at this, what DC sweeps are good for is sweeping some input and looking at how the circuit responds. Okay, so we've gone through, and you can play around, we've gone through transient, DC sweep, and operating point. These other ones, the DC transfer, you can probably play around with that if you want. That I hardly ever, I don't know how many, I could probably count how many times I've used a DC transfer on one hand because I get the information in better ways from the other simulations. Noise, that's an advanced simulation, and AC analysis is more for electronics when you're doing small signal analysis. So the ones we've covered, transient, DC, and operating point, cover 80+% of the simulations. AC will maybe 15%, and noise 5%. So I'm not sure you'll do any AC or noise analysis in circuits, just because they're not that useful. All right, so before I quit, what I will do is I will zip this file up. Let's go ahead and do it right now. Let's go File, Write, Add to Archive. Let's make it a zip. And then if you come back over to CMOS EDU, and you click on Videos, and then you come down here to 220D, I will put the notes, the video, and the PDF or the zipped file of the simulations here so that you can download them. Note, if you want even more information, you can come over here and click, and there's some other examples that I did before. What I'm planning on doing, though, is doing the rest of these live so that we can work problems from your book and cover things and you can ask questions. So let's go ahead and stop.